All right, you guys, we are on lesson 3. This is functions, and I'm going to be talking a lot about function notation. Again, this is just the answer key that's been posted. This is a brief explanation of each of the problems. If I go too fast, if you didn't understand something, if you need more of a refresher, please come see one of us on an optional Friday. Okay, that's what this is for, but I just want to very briefly touch on how I did each of these problems. So you have an idea. And again, this is stuff that you should have learned in Algebra 1 as well as Algebra 2. So for some of you, it's been a while since you've learned this kind of stuff. So let's refresh our memories, okay? Question 1, we've got a very basic problem. We've got f of x. What I want to remind you here is that this is just function notation. The way you read this is f of x. It means the f means function. This is a function, and I'm using the variable x in it. As you know, sometimes you see f of a, which means there will be an a in the equation. Sometimes you see f of y, which means there will be a y in the equation. Whatever, it doesn't matter. But it asks you for what is the value of f of 144. And so notice how f of x is the way the function is. But look, we've got an x here, and so they're telling you to replace the x with 144. The 144 has literally taken the place of the x here, so you're going to take the 144 and plug it into the equation right here. When you do that, you just have this 4 plus radical 144 when you plug in 144 for x. 144, radical 144 is 12, 4 plus 12 is 16. Another thing that's probably important to remind you when you did this whole polynomial unit, which was part of functions, you learned how to factor stuff, and when something is factored and equals 0, then you need to be able to figure out what the solutions are, okay? So when it's in parentheses like this, these are called the factors. When you were asked like a bajillion times in Algebra 1 and Algebra 2 to factor something, you left your answer like this. That's why I wrote these are the factors. How to get the actual solutions or the zeros or the intercepts or the roots. These are all different words that can describe that. I'm going to actually write that. Roots, zeros, x-intercepts. Those are all synonymous. They all mean the same thing. But in this case, they're using the word solution. So that means I'm going to take this x minus 4 and equal it to 0. And that means when you add 4 to both sides, you get positive 4. X plus 2 equals 0 when you subtract 2 from both sides. This is what I'm doing. I'm just solving for x, right? So I get plus 4. Here I'm subtracting 2 from both sides, so I get negative 2. Here I'm adding 1 to both sides, which is how I got 1. So these are actually called the solutions. So notice the difference. This is something really important to make sure you remember from this unit when you were in algebra. These are called factors. And then when you equal them to 0, these are called the solutions or the roots or the zeros or the x-intercepts. There's a bunch of different words to describe that. And this is asking for the product of the solutions. Product means multiply. So I'm taking the 4 and the negative 2 and the 1 and multiplying them together, and that is why we get negative 8. All right, for number 3, I'm going to kind of explain this 3 different ways. Again, we have this equation, and they're telling you to plug in negative 1 for x. When there's a bunch of x's, yes, you plug it in for all of the x's. And so that's what I did here. I just took the negative 1 and cubed it. Where did I get that from? Because it says x cubed plus 3 times negative 1 squared. That's what happens when you plug in negative 1 here. Minus 6 times negative 1. Careful with the double negative there. We have a lot of double negatives. And then this negative 1 hanging out at the end is that negative 1. So when you crunch that number, just be very careful if you're using the calculator that you're using parentheses. Negative 1 to the third is negative 1. When you square negative 1, it becomes positive 1. So when you multiply positive 1 by 3, make sure you follow order of operations. You get positive 3 here. Those two double negatives make positive 6. And then I have negative 1 here, and that gives you 7. Anyways, I'm not sure if you remember how to do synthetic division. This is one of my favorite, quickest ways to do a problem like this. You take the negative 1, what you're plugging in, and you put it in this thing that I like to call the backwards L box. And then where did these numbers come from? That is the coefficients of everything up here. So there's a 1 in front of the x to the third. There's a positive 3 in front of the x squared, negative 6, negative 1. Those coefficients go right here. If you ever skip any, like if there wasn't an x term, for example, remember you'd have to plug in a 0 like as a placeholder. But we have x to the third, x squared, x, and then whole number so that we didn't skip any variables there. Anyway, so once you have your negative 1 in your backwards L box and you have all of these coefficients lined up here, the first thing you do is you bring this number straight down. And then you take the 1 times the negative 1, multiply. 1 times negative 1 is negative 1. And then you add. Okay? And then you take the 2 times the negative 1 and put it here. And then you add. And then the last thing you do is you take the negative 8 times the negative 1 and put it here. And then you add. And so you can see we got 7 here when we plugged it in like old school style. And we also got 7 here. This is the answer. I don't know if you remember synthetic. I don't know if you remember learning this. But this method is very, very fast. And you don't have to worry about making mistakes with exponents when you do this method. But either way, whichever one you're comfortable with, whichever one you think you're more likely to remember and crush and get the right answer every time, that is why we get C for 7. So you do you, whichever one makes more sense to you. All right, number 4, we're given a t-chart. You know what a t-chart is. It's a combination of ordered pairs. And I like process of elimination for this problem. So the very first ordered pair on this t-chart is 0, 0. So let's look at our graphs here. This graph, it looks like it goes through 0, 0. This graph does not go through 0, 0. So I'm going to cross that one out. This one does, and this one does. I have little black dots at 0, 0. So I eliminated one answer choice. I'm going to now do the next ordered pair, 1, 1. Let's see if I can eliminate any others by looking at 1, 1. Well, here's 1, 1. That's not on the graph. This graph does not go through the ordered pair 1, 1, so I'm going to cross that one off. C is already gone. Let's look at B. B goes through 1, 1. Check. Let's look at D. Oh, interesting. So notice that the units here, 1, 2, 3, 4, these go by ones. 1, 2, 3, 4. Sometimes they might trick you and they might make these boxes go by 2s or something. So just be careful of that. But it looks like this ordered pair does not, or this graph does not hit 1, 1 perfectly. It hits a little bit short of that. So I'm going to eliminate this one also. And by process of elimination, very quickly, I come up with letter B. How about this guy? We've got a polynomial here, and it doesn't give us any numbers about it, which is fine. It just says A, B, C, and D are constants. That's a little bit annoying, but whatever. For how many values of x does f of x equal 0? So f of x is just a fancy way of saying y, and y equals 0 is a horizontal line. So I'm looking at the x-axis here. This red line right here is the horizontal line, y equals 0. And how many times does that red line touch the graph? I put dots there. I put a dot right here, I put a dot right here, and I put a dot right here. And those are the zeros, or the roots, or the x-intercepts, or the solutions. Remember all of those synonymous words? What did we write down here? All of these is what it's asking about. They're all interchangeable. But right here it says how many values of x. So I'm reporting the x numbers, this one, and this one. Looks like there's 3 of them that touch y equals 0, which is why I'm having 3. Number 6, the graph of y equals f of x is shown here. What's the value of f of 0? Remember how it's f of x, so they have replaced 0 with x. So we need to find when x equals 0. Here's when x equals 0. I'm right here. I'm going up to 3. I circled it, but the y value there is 3. When it asks you f of some number, it's giving you half of the ordered pair, kind of like this, 0, comma, and it's asking you what number goes there. In this case, the y value of this ordered pair is 3. All right, we kind of have another substitution question here. We already did a lesson on substitution, but I'm noticing that both of these equations equal g of x, and yeah, it's okay to use f of x, g of x, h of x. If you remember this chapter, they use all different variables for the letter in front of the parentheses with the x. In this case, they're both g of x, but since they're both g of x, that means that this equals this. It's a substitution problem. That's why I wrote this equation. Now I just need to solve it. I'm canceling 9 on both sides, and then don't forget how to cancel a square. You do a square root, and don't forget your plus minus since we are solving an equation, but the only answer choice that is available here is 4. Fun fact, you can also do process of elimination here. If you plug in 4 right here and square it, and then add 9, you get 25, so that is check. How would I process of eliminate if I was checking the 5? Well, when I take 5 and square it, I get 25 plus 9 is 34, which is not 25. So that is not the answer. That's another way to go around this question. Number 8 is very similar. I have f of x and f of x. Therefore, I'm going to equal this to this. And that's how I got this equation. Just don't get going too fast on this because I can understand where there might be some mistakes on a problem like this. Is first I'm going to divide 8 on both sides. And then remember how to get the square root of x, how to get the x by itself. We don't square root it, we square both sides. So when you square the square root, that is how you get x by itself. Therefore, I need to square this side to get 36. You can also do the process of elimination like we talked up here. You can take the 6 and plug it in right there. 8 times the square root of 6 is not 48, so I would cross that out. When you plug in 8 right here, square root of 8 times 8 is not equal to 48, so I would cross that one out. When you take 36 and plug it in right here, the square root of 36 is 6, and when you multiply that by 8, you do get 48. There's our winner. Okay, I've got 2 more here. Number 9, the function here is 7x to the third. Okay, I love these. This is a pretty common question. And they're translating this, if you remember translations from when you were in Algebra 2. How do you move a graph that looks like this? Up, down, left, right. So I don't know if you remember doing like parabolas, for example. Let me do a side problem here. This is y equals x squared, or f of x equals x squared. Do you remember how to shift a parabola like left, right, up, and down? So I'm going to give you an example. X plus 3 squared actually moved this graph left 3 units. Do you remember that? When the number is inside the parentheses, you actually go the opposite direction that you think that you should, which would be left 3. If it was, this is a very crash course on parabolas, just to remind you, this would be right 3. And then if I take the x squared and add 3 without the parentheses, that would be up 3. And then if I take y equals x squared minus 3 without the parentheses, that one would be down 3. Okay, so I don't know if this is refreshing your memory at all, but when you have a plus 3 inside the parentheses here, that actually indicates that you move left 3. A plus 3 outside, like all on its own, indicates up 3. So notice the difference. Here we're back inside the parentheses with a negative 3. That actually means right. So your left and your right movement happens inside the parentheses, and your up and your down movement happens outside of the parentheses. I just wanted to kind of see if that helped before I explained this problem. So now we have an x to the third graph, which if you remember what an x to the third graph looks like, it looks like this. It's got a little kink in it. Okay, but we've got this 0.00. If I want to move this thing down 2 units, then I'm actually literally taking this thing and I am moving it down 2 units like this. As opposed to for the parabolas, we can move left, right, up, down. But how do we move down? What we're doing is we're just taking a negative 2 on the outside here. So it doesn't have anything to do with multiplying or dividing or anything with like the square root or the exponent on the x. So we can eliminate both of these answer choices pretty quickly. Make a note to yourself that that plus 2 would shift this up 2 units. And this is asking me to shift down 2 units, so I'm just subtracting a 2 here. I'm going to continue this discussion on number 9. And yes, if you're familiar with Desmos, that is the calculator that you're going to have available to you on your iPad when you take the SAT digitally. We're going to be practicing that a little bit later in class, okay? But if you're familiar with Desmos, you can type this into Desmos and all of these answer choices into Desmos and see which one actually translated this thing down 2 units, like that, okay? And it ends up being D. The last one, continuing that discussion that we were just talking about. So this is kind of a little bit of a harder question. I usually save my hardest one for last. But again, we have another polynomial here. And remember that these are the factors similar to one of those earlier questions that we did in this lesson. When you take this factor and equal it to 0, you get the first 0, which is -6, which means -6, 0 is on the graph. I'm actually going to sketch what this might look like. -6 is the first 0. I'm going to put that right here. This is the first dot. This factor right here gives me a -5, doing the same exact thing. So I'm going to put a dot at -5. And this factor over here, x minus 4, when I equal it to 0, I get +4. These are my 3 zeros for this polynomial, and it looks something like this. It has the same shape because it's an x to the third graph. And again, if I want to move this thing down 3, then that's what this means, is this -3 that's outside of the function, outside of the parentheses, okay? That means down 3 units. So I'm just taking all 3 of these ordered pairs that I just put on my graph right here, and I'm going to shift them all down 3 units. When you subtract 3 from each of those, it affects the y values, right? So that means that my x values stay the exact same, but my y values go from 0 to -3. Take 0, subtract 3. Take 0, subtract 3. So I'm looking for these ordered pairs, and you have to look really carefully. It's a little bit annoying that they gave us all of these t-charts to look at. You have to look very carefully. This one is not the right answer because this has +3s. Be very careful. These are all -3s because we're subtracting 3 because we're going down 3. Okay, but that is why we get the 3 zeros as the x values and then the -3s as the y values, okay? Thanks for watching. Again, I encourage you to come in on an optional Friday if you have questions about this, but this is your crash course over functions. Thanks for watching.